let's recall this. If we multiply conjugates, like say we have x plus y and x minus y conjugates, we have a rule for this. We square the first, put a minus sign, and square the second. Now if we look at an example, what if we have something like this? What if we have 5 plus square root of 3 and 5 minus square root of 3? So we've got radicals in here, but what happens when we multiply these conjugates together? Well, let's identify this factor here. We'll square the first, getting 25. We'll put a minus sign, and then we'll square the second. So when you square a square root, you know the radical comes off, so we just get 3, and we end up with 22. What we want to observe here is that when you multiply conjugates with the radicals in them, the radicals disappear. So this is a good way of getting rid of radicals. If we have a two-term denominator multiplied by a conjugate, the radical will disappear. So let's use that in these problems here, both number 83 and 85. So in 83, what we're going to do is we're going to multiply. Now I'm going to go through this whole thing again, but this is a step that you could skip. We're going to write this. 9 divided by 4 plus square root of 3. We're going to multiply by 1, but the one that we're going to pick is this. 9 over 4 plus square root of 3. Let's pick the conjugate of this denominator, because what we did in our work right over here, we know if we multiply conjugates with radicals, the radical disappears. And that's what we're trying to do here. We're trying to get rid of this square root of 3. Back in the original problem, we're asked to rationalize this denominator. That means get rid of all the radicals. So let's write 1 as the conjugate of 4 plus square root of 3, which is going to be 4 minus square root of 3, 4 minus square root of 3. And let's multiply. We'll start just by indicating the multiplication. I'll take 9 and multiply it by 4 minus square root of 3. I won't actually multiply it yet. I'm just going to indicate it. And then the denominator, we're multiplying conjugates. So we know what to do here. Square the first. Made a mess there. 16. Put a minus sign, square the second. And when you square the square root, the radical comes off. So we end up with a 3. So now we're going to have 9 times the quantity 4 minus square root of 3 all over 13. And that's probably the best we're going to do out of this one. The 9 and the 13 we can't cancel. And I don't really see any advantage of multiplying this through. So let's just say that that is our rationalized, that's our simplified form with a rational number in the denominator. Let's rationalize this denominator here in number 85, right? It's irrational because we got that square root of 5. So we're going to multiply, I got two terms here. So I'm going to multiply top and the bottom by the conjugate of this denominator here. That's going to look like this. We're going to have the square root of 3 over square root of 5 plus 2 times the conjugate of that denominator. Square root of 5 minus 2 over square root of 5 minus 2. And I'm just going to indicate this multiplication in the top for now. We'll get square root of 3 times the quantity square root of 5 minus 2 over, now we've got conjugates here, so we know what to do. Square the first, put a minus sign, square the second. So when you square the first, square a square root, we know the radical comes off, so we get a 5 minus, now square the second, 2 squared will give us a 4. Okay, so this will give us square root of 3 times the quantity square root of 5 minus 2 all over 1. Or how about just square root of 3 times square root of 5 minus 2. You know, this is probably okay, but if you wanted to, you could go ahead and multiply through here. So what are we going to get? We're going to get the square root. Both the 3 and the 5 are under the radical, so we'll get 15 minus, now when you multiply here, the 3 is under the radical, the 2 is not, so they'll stay that way, 2 square roots of 3. So either one of these forms is good.